malam. Okey, jadi terima kasih kerana terus setia bersama dengan kami untuk slot yang keempat dalam siri webinar Jom Skor A+ Matematik Tambahan bagi SPM 2021. Jadi tajuk kita pada malam ini ialah Indices, Surds and Log. Okey. Jadi sebelum kita bermula, jadi sukacita cikgu ingin mengingatkan kembali kepada para pelajar semua untuk tentang beberapa perkara, iaitu slot ini akan dirakamkan dan untuk tujuan tontonan semula, okey, jika pelajar ada keperluan untuk menonton semula video pengajaran ini, jadi pelajar-pelajar hanya perlu klik semula di link yang sama, okey. Yang kedua, link kehadiran akan dikongsikan oleh saudara produser kita apabila sampai pada masa yang sesuai. Jadi mohon untuk pelajar-pelajar setia kekal bersama kami di sepanjang slot webinar ini. Jadi biasanya link kita akan kongsikan sama ada di ruangan Q&A dan juga di grup Telegram kita. Yang ketiga, jika pelajar ingin bertanya sebarang soalan, jadi pelajar-pelajar boleh menggunakan fungsi Q&A. Jadi mohon juga agar pelajar-pelajar untuk tidak bertanya soalan yang sama berulang-ulang kali. Okey, mohon juga beri masa kepada guru-guru untuk menjawab soalan anda dan adalah lebih baik semasa pelajar-pelajar bertanyakan soalan itu, mungkin boleh nyatakan nombor example yang mana yang pelajar rujuk untuk bertanyakan soalan tu. Okey. Jadi tanpa melengahkan masa, seterusnya cikgu ingin memperkenalkan penceramah kita pada malam ini, iaitu Cikgu Hazlina binti Ahmad atau Muhammad Zailani dari MRSM Alur Gajah. Beliau berkelulusan Bachelor Sains Kepujian dalam bidang statistik UPM dan beliau turut mempunyai Master of Professional Science dari UTM. Okay. Jadi pengalaman mengajar Cikgu Haz, beliau memulakan tugas di MRSM Muazzam Shah, bermula pada tahun 2005 sehingga 2007 dan seterusnya beliau berpindah ke MRSM Alur Gajah pada tahun 2008 dan masih kekal di MRSM Alur Gajah sehingga sekarang. Okay. Jadi saya turut ingin memperkenalkan tim yang bersama-sama dengan kami pada malam ini. Seperti biasa, Cikgu Ji Hamzah selaku produser pada malam ini dan fasilitasi yang bakal bertugas untuk menjawab soalan-soalan daripada para pelajar adalah Cikgu Rosdana Sarju dari MRSM Johor Bahru, Cikgu Muhammad Hasbullah Nawawi bin Cik Ismail dari MRSM Sungai Besar dan tidak lupa yang turut bersama dengan kami ialah Puan Nurizan Kasah, TP2 Matematik kami. Jadi seterusnya tanpa melengahkan masa, saya serahkan sesi ini kepada Cikgu Hazlina. Dipersilakan.
Terima kasih MC. Okay, Assalamualaikum warahmatullahi wabarakatuh. And a very good evening to all students, teachers and semua yang menyertai webinar kita pada malam ini. Okay, untuk memohon keberkatan untuk webinar malam ini, kita panjatkan doa dululah kepada Allah SWT agar apa yang bakal disampaikan malam ini mendapat keberkatan untuk semua. Rabbi syrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam walhamdulillahirabbil alamin. Amin ya rabbal alamin. Okay, this is the first webinar kita untuk sepanjang daripada bulan hari itu sehingga ke hari ini. Kita start dengan IGCSE and then we ada functions, kita ada quadratic functions and lately yang terlatest kita ada systems of equations and now kita akan seterusnya kepada tajuk seterusnya ialah Indices, Surds and Logarithm. Yang ini tajuk ni adalah chapter 4, form 4. Kita belajar masih chapter 4, form 4. So kita akan lanjutkan lagi kepada Surds and Logarithm, and before we go to any further of this logarithms, this topic, suka diingatkan agar pelajar-pelajar semua bersedialah dengan peralatan, dengan kertas semua. Kalau ada yang bahan yang telah di-share, boleh gunakan bahan yang tersebut ya. So teacher akan conduct this webinar gunakan dua bahasa, BI dan juga bahasa Melayu bagi memudahkan semua. But terms in mathematics teacher akan kekalkan dalam bahasa Inggeris. Okey, semoga kita sama-sama mendapat manfaat lah daripada webinar ni. Okey, kita mulakan ya. So indices, surds and logarithm. So before we go to any further of this topic, kita recall back our knowledge on this, your prior knowledge in these topics. Okay, this topic indices is actually you have learned these topics in mathematics masa form 3, chapter 1 under topics indices as well. So under these topics, you diajar tentang dua subtopics which are index notation and next will be laws of indices. Kita start dulu apa yang you belajar masa first in chapter 1 form 3. So you learn about index notation ya. Okay, apa index notation tu macam mana? Sebelum tu kita belajar pasal kenapa kita belajar indices ni ya. Indices ni is actually we learn about numbers. Numbers selama ni kita cuma cakap numbers macam nombor 4, nombor 6, nombor 8. Itu nombor yang biasa kita sebut, kebiasaan kita sebut 4. Sometimes nombor tu kita boleh express the number in other form. So one of the form is index notation lah. Contohnya macam nombor 2, nombor 4. 4 tu kita boleh cakap juga dia adalah 2 kuasa 2. 2 kuasa 2 tu macam dia ada power kan. Itu yang kita sebut sebagai index notation. So what is index notation? Kita tengok kejap ya. Apa dia index notation tu? Okay, this is index notation is written as A to the power of N. Kita nampak kat sini kan ada A besar. The red one tu is base kita. Apa yang A tu yang besar tu? What is the blue one? The red one tu kita kenali dia sebagai base. Okay, it's a base. And the smaller number yang superscript tu kita panggil dia sebagai is index. So base index. What does it mean by A to the power of N? Kita sebut sebagai A kuasa N ataupun dalam bahasa Inggeris A to the power of N. It is actually A to the power of N is A to multiplied by itself 4n times untuk 6 kali contohlah. So dia multiplied by itself. Dia darab dengan diri dia sendiri. For instance macam A times A times A times A until n factors whereby A is not equals to 0. Maksudnya nombor tu didarab dengan diri dia sendiri. Kalau 2 kuasa 3, maksudnya 2 darab 3, 2 darab 2 darab 2. Contohlah. So kita recap back what you have learned last time. Recap Take a look at this. Recap 1. Write the following repeated multiplication in index. Okay, kita kena tulis this one kita panggil sebagai repeated multiplication whereby 5 to multiplied by itself. Kita kira ada berapa kali? 1, 2, 3, 4, 5, 6. 6 times. Repeated 6 times. Maksudnya 5 tu dia multiplied by itself for 6 times. How to write it in index notation? It is 5 to the power of 6. This is how we write it. Instead of writing in repeated multiplication, we can write it in index notation which is 5 to the power of 6. Okay, itu cara dia lah. And yang ni diguna pakai untuk semua nombor. Integers ataupun whole number, decimal and also fraction. Semua boleh guna pakai ya. Now, recap 2. Kita tengok pula. Numbers. Numbers for instance 64. Write 64 in index form using of base 2, base 4 and base 8. Maksud dia dekat sini adalah nombor 64 tu nombor yang biasa kita tulis. Somehow 64 tu also we can express it in base in index notation. Okay, such like dia kata base 2. Maksudnya 2 kuasa berapa dapat 64 ni. Okay, meaning that what you do is you just multiply 2 by itself sampai you dapat 64. So for instance, you darablah 2 darab 2, 4 darab dengan 2, 8 darab dengan 2 lagi, dapat berapa? 16 darab 2 lagi, dapat 32 dan darab 2 lagi. Itu maksud dia. So you akan dapat is actually 2 to the power of 6. So nampak tak sebab dia multiplied by itself for 6 times. So that's why you dapat 2 to the power of 6. Somehow 64 also you can express it in base 4. Base 4 pula maksudnya kita start dengan 4 lah. 4 tu darab dengan diri dia sendiri berapa kali until you get 64. It is 3 times. Sorry ya. 4 times 4 times 4. This is how you write it. Instead of you write it in nombor yang biasa, you express dalam nombor yang biasa, you can express it in index form. Okay. Whereby the nombor besar ni kita panggil sebagai base, the smaller one is index. Yang kuasa ni kita selalu panggil dia kuasa kan. So dia sebenarnya adalah index. Okay, ataupun dalam base 8. So 8 to the power of 2 also 64. Nampak 64 tu ada 3 yang kita boleh express dia dalam base 2, base 4 or base 8. One of this one. This is what you have learned dalam subtopik pertama dalam form 3, which is you were introduced to the index notation. Okay. Secondly, okay, reminder kat sini, you nampak kat sini ada satu pop-up kat situ. Dia kata 2 kuasa 5 is not equals to 2 darab 5. Ni kena ingat ni, kena hati-hati ya students ya. 2 kuasa 5 tu bukannya 2 darab 5. 2 kuasa 5 tu maksudnya 2 times 2 times 2, dia repeated. Dia multiplied by itself for 5 times. So dia bukan jadi kalau 2 darab 5 10 kan, tapi 2 kuasa 5 adalah berapa? 32 kan? 2 kuasa 5 adalah 32. Okay? But 2 times 5 adalah 10. Tak sama kan? That's why dia kata tak sama. So come to the conclusion that a to the power of n is not equals to a times n. You have to remember that. Okay, now next, lepas kita belajar index notation, kita belajar apa? Kita belajar laws of indices. Okay, laws of indices ni ada dalam chapter 4 form 4 4.1. But somehow we have learned this laws of indices in form 3. Remember? Prior knowledge. This is what you have learned. So I list here the laws of basic laws that you have learned dalam form 3. There are 3 laws here. This one, the first one ni yang A, base A to the power of m times A to the power of n. So ada darab, base dia sama. Kita boleh sum up dia punya index ni. You just add the index together, it will be A to the power of m plus n. Macam mana dapat macam ini? Let's check ya. Kita tengok how we come up to this formula. So kita tengok, for instance, let's say we have this multiplication of numbers in index form. Let's say we have 2 to the power of 3 times 2 to the power of 4 here. For this one, kita dah nak tengok tadi masa slide pertama tu, 2 power of 3 adalah dia represented by this one, 2 darab 2 darab 2. Whereas 2 to the power of 4 is written as this, as a repeated multiplication will be this, darab kan. So if you combine them together, you will get berapa? Ada 7, 2. 1, 2, 3, 4, 5, 6, 7. So meaning that you can conclude that 2, the repeated multiplication is 2 to the power of 7. Macam mana dapat 7 ni? How do you get 7? Cuba kita relatekan dengan the first one ni, yang 2 kuasa 3. It is by adding these two index. 3 plus 4, you get 7. So that's why pertama tu yang multiplication law ni dia kata yang ini. They come out to the conclusion that this is the product rule. Remember, we are talking about the index. Kalau index tu yang base sama, you just add the index. Okay, the second law. This is kita panggil sebagai division law ataupun quotient law. So kalau yang ni pula, you can nampak A base sama perhatikan sini. Base mesti sama dengan syarat. A to the power of m divide by A to the power of n. What happened to the index? You just minus them. M minus n. Okay, dia jadi minus. So macam mana? How do you get this? So kita tengok example ya. Example of law 2. You tengok sini ya. 4 to the power of 5 divide by 4 to the power of 2. So if you use the repeated multiplication like this, divide maksudnya kita bahagi macam ni, right? So 4, 5 ni, 4 to the power of 5 ni, maksudnya my repeated multiplication akan ada 5 sini. While yang the other one tu, denominator will be ada 2 4s. Untuk kat sini, you can see clearly that you can eliminate this one. Ataupun kita simplify this. We'll get 1, 4, divide by 4, this one as well. And then what is left is ada 3 orang ni je yang left. Okay, that's why it is 4 to the power of 3 because of it is repeated 3 times yang the left one. So how do you get 3? Bila kita nak relate dengan the first one ni, it is by 5 minus 2. You get 3. Nampak tak? Dia punya power tu kan, kaitan dia di antara yang ini dengan kesimpulan sini. So come out to the conclusion that the division law will be, kalau ada division, what we do is we just minus the index tu, tolak. Okay, now the third rule kita panggil dia sebagai power rule. Normally kita akan panggil power rule lah, whereby kalau kita tengok dekat sini ada satu a to the power of m, and then dia ada power lagi, dia ada bracket here, to the power of n lagi raising power. It will be a m darab n. Okay, how do you get this? Macam mana kita boleh conclusion macam ini? So kita tengok dia punya example. Let's say, what does it mean by 3 to the power of 2 power of 4? Okay, it is meaning that this one, 3 kuasa 2 ni dia multiplied by itself for 4 times. Itu maksud dia. So boleh tengok dekat repeated multiplication here. Ini 1, 2, 3, 4. 4 kali kan? So 3 to the power of 2 multiplied by itself for 4 times. So bila kita nampak ini, this is multiplication law. You nampak tak ada darab ni? So bila dah ada darab ni, maksudnya kita boleh guna the first law. So meaning that we just add the index together. 2 plus 2 plus 2, you get 8. How do you get 8? From here, it is by multiplied 2 dengan 4. So akan dapat conclusion whereby kalau ada bracket ni, kuasa ni, kita boleh gabungkan jadi a to the power of mn. Okay, clear ya? Okay, now from here dia ada lagi satu kat sini. Cuba tengok dekat remark here. Dekat remark here, you nampak kat sini, right? A to the power of m and b to the power of m. Obviously, we can see that the base is not equal. So definitely we cannot use these three laws here. Multiplication especially because it is darab kan. So why? Because of base dia tak sama. Bila base tak sama, you take a look at the index here. Index dia sama kan? So kalau base tak sama, kita check for the index. If the index is equal, so what we did is kita just combine them, multiply a and b. You akan dapat a times b power of m. Okay, this one same goes to multiplication, division pula. Division is a power of m divided by b power of m, whereby the base is not equal. Berbeza kan, a dengan b kan tak sama, but the index is equal. So what we do is kita combine this part, the division part tu, a divided by b power of m. Okay, you have to check this. Remember, in order for us to solve, to simplify the indices, first thing first, we should check adalah dia punya base. Make sure the base is sama, equal. Baru kita boleh gunakan laws tu. Or else kita tengok macam mana kita nak solve. Okay, next. Kita pergi pada yang ini pula. The properties of the indices. Yang ini sangat glamour. Kita jumpa dekat mana-mana topics. Bukan saja dalam indices, dalam calculus, and so on. Apa saja kan. So dia kata a to the power of 0 is 1. And kadang-kadang students pun sampai form 4 pun form 5 pun dia tak tahu macam mana a to the power of 0 is 1 teacher. Dia tak tahu, yang dia tahu dia guna je. Kita just guna. So kita tengok dekat mana, macam mana dia nak proof, macam mana dia derive this formula. So kita tengok example 4 kat sini, dia tunjuk macam mana division index form dengan dia ada comparison between laws of indices dengan repeated multiplication. Okay, let's say kita bagi example, the same one. 2 to the power of 3 divide by 2 to the power of 3. Kan dia divide dengan sama, benda yang sama divide. So bila kita divide, kita tahu kan, we use, because of division kita gunakan, this is division. So we are going to use this division law. Division law means kita minus dia punya index. So 3 minus 3. 3 minus 3 is 0. So it will be 2 to the power of 0. Kita simpan dia kejap. Okay, now kita pergi pada repeated multiplication using the same questions here. So bila repeated multiplication, what we did is we just multiply yang numerator 2 times 2 times 2 divide by denominator 2 times 2 times 2. This one definitely kita boleh simplify. Kita eliminate dekat sini, you will get 1, isn't it? Betul tak? You dapatkan 1 kan? Macam 3 divide by 3 contoh, kan dapat 1. Nombor exactly the same. So meaning that, nampak tak yang apa yang teacher bulatkan kat situ? So this one is meaning that kita come up to the conclusion that 2 to the power of 0 is equals to 1. So itu yang menjelaskan kenapa any number, bukan 2 sahaja tau. Any number, when it is power is 0, it will be 1. Itu je, itu menjelaskan macam mana you dapat benda ni. Okay. Now kita pergi pada the second one. Yang ini negatif. Indices dia tu adalah, index dia adalah negatif. Kita panggil dia sebagai negative indices ya. Okay, this is negative indices ya. So how you get this? How to prove this? How you derive this? So kita tengok example untuk 5 untuk yang indices ni, prior knowledge. So you tengok, so division. Let's say kita ambil 2 kuasa 3 divide by 2 to the power of 5. So kita gunakan 2 method. One is kita gunakan loss of indices. Another one is repeated multiplication. So loss of indices, when it is division, we just minus this one, the index. 3 minus 5. So 3 minus 5, you get negative 2. So you keep this in your pocket first. Okay. Now we go to the repeated multiplication. Okay, again kita gunalah, kalau 2 kuasa 3 tu maksudnya 2 tu multiplied by itself 3 times, yang ni 2 multiplied by itself for 5 times. So this one again kita simplify, isn't it? Kita simplify this one dengan ni, satu ni, satu, yang tinggal 2 adik-beradik ni kat bawah tu. So atas tu jadi 1, yang bawah tu 2 kuasa 2. Nampak tak teacher bulatkan this one? Now you make a conclusion that 2 to the power of 2 is actually 1 over 2 power of 2 kat sini. Kalau sini negatif bawah, kalau dia pergi bawah macam it seems like dia jadi positif. So we can say that this one is such like the reciprocal of this one, a to the power of negative m. Reciprocal adalah 1 over something, right, itself, but dia punya index will be positive, tukar. Instead of negative index, dia akan jadi, kalau buat reciprocal, dia akan jadi positive. This is basically that you have learned in form 3. Okay. Now, baru kita pergi seterusnya kepada soalan, example. Ready semua kita sekarang nak jawab soalan-soalan, nak simplify the indices. Okay, bismillahirrahmanirrahim. Okay, this one pula. Okay, daripada sini kita dapatlah tips kat sini. Kalau sini negative, positive, A ni. So, reciprocal of this one, automatically this one akan jadi negative. And then, dia punya index. For this one juga kalau ada fraction kan, kalau negatif and then dia interchange A and B, the index will be positive. Okay, ini semua dah kita tengok masa form 3 ya. Now kita pergi pada example 1. Ready semua? Hopefully you ready. Kita tengok. Remember, kalau kita nak bear in mind, we want to simplify the index ke apa, kita mesti tengok dia punya base dahulu. Okay, first kita tengok yang ni dulu. 5, simplify the following algebraic expression. Simplify means you kena tulis dia dalam bentuk terringkas lah. Tak nak yang ini macam ada banyak 5 kan, kita nak tulis dia dalam single index. So contoh index number. So for instance here kita tengok 5 to the power of 3x darab dengan 5 to the power x divide by 5 to the power of negative x. So here we can see that dia menggunakan base yang sama, same base ya, 5, 5 and 5. So definitely, and then the first part numerator ada darab, kita menggunakan multiplication law, while this one kita menggunakan division law kat sini, right? So because of 5 kat sini kita pun buat apa? Using this law. This is the first one adalah multiplication law, whereby you just add them together. 3x tambah dengan x. That's why teacher add kat sini. 3x plus x. And then another one dia ada negative, isn't it? Minus. So minus, nampak tak kat sini negative, right? So write accordingly. Minus, you put a bracket here to avoid any careless mistakes. So negative later on will be positive. So yang this one kita gunakan division. We use 2 laws here, multiplication and division law. So at the end you get 5 to the power of 5x. Okay, this is quite easy because the base is same already. Dah sama dah, tak payah nak buat apa-apa. So now kita pergi pada the second one, B. B we check first. Remember, check the base first. Okay, kita tengok fraction as well. So you have 9 to the power of A minus 3 multiplied by 9 to the power of A plus 4. You can see clearly here the base is 9. Tapi kat bawah denominator is 81 kan? 81 tu bukan base 9. Tapi kita boleh convert this 81 to base 9. Whereby 81 is actually 9 to the power of 2. So what we did is kita tukarkan. Instead of 81, kita jadikan dia 9 kuasa 2. Kenapa? Kita nak base dia mesti sama. Okay. Use base 9 for all terms. Itu syarat dia. Kenapa teacher? Because we want to use the laws of indices tadi tu. So dari sini baru kita nampak ada darab and juga bahagi. So what we did is add and subtract the indices using the laws of indices. Refer to this one. Nampak tak yang teacher dah buat kat sini kan? Yang pointer teacher gerak tu. Kita akan mengguna ni. Kalau darab kita plus, kalau bahagi kita minus because they have the same base here. So maksudnya 9A minus 3 tambah A plus 4 minus 2. Macam ini. Right. This one is the first one, 9. This one is the second one and minus 2 is kita minus yang because of ada division situ. So kita simplify je atas ni. A plus A will be 2A. This is the final answer. Isn't it? Senang kan? Macam tu je lah. Because of base dia sama. This is simplify. Nampak tak? From the complicated form, it will be the very simple one. From the complicated one as well here, you get the very simple one. That's why kita panggil simplify. Okay. Next, kita pergi to the next question, to the next example. For this one, simplify as well. Kita masih dalam simplify lagi ya. Okay, this one, simplify the following algebraic expressions. Kat sini dia ada symbol set. Symbol set kat sini. Kita dah belajar masa form 3 tu. So kita kena tukar. First thing, you know that, kejap ya. Okay, set ni, for instance ya, kalau A, set A, this one is actually kalau tak ada nombor dia kuasa dia set square root lah. It is equals to A to the power of 1 over 2. Macam tu. Tapi kalau kita ada macam ni A, this is A and then dia ada set A order 3 kita panggil ni. Kita tulis dia sebagai A to the power of 1 over 3. Set tu kan. And then what if kalau kita ada macam ni A to the power of N. Kalau kat sini ada M. So dia akan jadi A to the power of N over M. Macam tu. So we are going to use this one. So the first thing that we should do is kita buat macam ni lah. This is A. Instead of writing dalam bentuk set to solve this, to simplify this, we have to convert it to this form yang teacher buat ni. You have to convert it to this form. So this one will be 7 A to the power of 7 over 5 times A to the power of negative 9 over 4. And we can see clearly using the same base. So yang ni kita menjelaskan yang kat sini lah. Because this one we convert it from here to here. Okay. And then bila ada multiplication here, kita gunakan multiplication rule. You just add the index together. This is what you get. You use this multiplication law. Tambah. So you akan dapat the end adalah A is equals to negative 17 over 20. Okay semua ya. Now kita pergi to the next one. Example 3. Show. Show punya questions. Example 3 ya. Show. Show is, kalau show kadang-kadang dia kata proof. Soalan kan proving. Show. Kat sini right. Show ke proving ke. Showing or proving is question yang ada answer. Cuma dia nak working step. Dia nak tengok macam mana you dapat. How do you want to prove that one? What is the working step you nak dapat? So first thing that you should do is you just write the questions here. I just copy the question back. 4 to the power of 3A minus 2 equals to 64 to the power of A over 16. Okay, what we do is mula-mula kita recognize left hand side dengan right hand side. Dipisahkan oleh equal sign here. This is left hand side, this is right hand side. So bila soalan showing, we want to prove left hand side to become right hand side or right hand side to become left hand side. Either one, which one that you prefer. Kalau you rasa lebih senang nak provekan left hand side to become right hand side, just go ahead. If you feel like right hand side to become left hand side is easier then, so just go ahead. Okay, so I'm choosing left hand side to become right hand side tonight. Okay, how I write it properly. You have to write this one properly ya. Jangan pakai suka-suka tulis mata-rata je dekat paper tu kan. So left hand side, I just copy everything back. 4 to the power of 3a minus 2. And kita nampak dekat index ni ada negative, ada minus 3a minus 2. Bila ada minus, meaning that something to do with this division law. Okay, apa yang kita buat adalah kita gunakan division law like this lah. A to the power of 3a over 4 to the power of 2. Why become like this? Because of this one. Kita gunakan division law. Okay. Selalunya kita buat macam ini, right? From here dia bagi macam ini pergi ke sini. This one, this time dia bagi macam ni, kita tulis this way pula. Macam inverse pula kan kat situ. Tak kisah mana-mana tapi kita faham kalau minus tu. Maksudnya division law. So bila kat sini, okay now dah dapat macam ini, kita pun buat apa? Kita carilah 4 kuasa 3 tu berapa? 4 kuasa 3 tu adalah 4 times 4 times 4 it is 64. 4 to the power of 2 is 16. So you nampak tak? You get this back. So this one is actually right hand side. So meaning that from left hand side, you dah prove dah dia akan jadi right hand side. This is how you do the showing punya writing. Okay, kena buat correctly. Now, kita pergi pula the second one. Again, show that as well. So you nak show kan, first of all, you tengok dahulu left hand side and right hand side here. So kita tulis right. So 9 to the power of 2a plus b equals to 81. In bracket tu maksudnya darab ya. 81 kuasa a. So now kita remark as left hand side and right hand side. Okay, again, I'm choosing left hand side to become right hand side. Doesn't matter if you want to choose right hand side to become left hand side pun boleh je, tak salah. So tulis dahulu left hand side is equals to 9 to the power of 2a plus 2. What I did is kita nampak clue dia plus. Bila plus meaning that kita macam it seems like you want to expand it. Kita gunakan multiplication rule. So you get 9 to the power of 2a times 9 to the power of 2. So gunakan multiplication rule here. So bila kat sini kita buat apa? Kita just cari je. 9 kuasa 2 adalah 81a, power of a. And then 9 to the power of 2 is 81. Okay, darab kan dalam kurungan. You cannot just simply darab 81 dengan tak boleh ya sebab dia ada kuasa. So now kat sini kita check dekat atas. Macam tak sama kan? Yang ni 81a dahulu. Tapi dekat atas tu 81 without a. So macam mana ni darab? Okey, kita cuba tengok dekat sini. Setengah student dekat tak tahu macam mana nak susun balik ni cikgu. So kita tengok. Cuba tengok dekat sini yang kita pop up ni. 2 times 4 is 8 kan? 4 times 2 also 8. So nampak tak? When it comes to multiplication, it doesn't matter which one multiplied with which one. You get the same answer. In this case, 2 darab 4, 8. 4 darab 2 pun 8. So tak kisahlah siapa darab siapa. Tapi guna nombor yang sama lah. So you get the same answer. For instance lagi, kalau kita ambil nombor 2 dengan 3. 2 times 3 is 6. 3 times 2 also 6. It doesn't matter. So maksudnya kita apply to these questions. Meaning that 81 power of 8 times 81 boleh juga kita tulis sebagai 81 times 81 power of a like this. So samalah dekat atas tu. So it is equals to right hand side. Nampak kita start dengan left hand side. We end with the right hand side. That's how you prove. Any proving ke showing punya question, this is how you prove it. Okay, boleh ya? Okay. Good. Kita pergi to the next question pula. Kita banyak show sekarang ni. Show. Sebab soalan sekarang dia banyak yang show. Dia tak suruh cari ke apa tu. Dah kurang sikit dah soalan-soalan guna calculator tu. Okay, kita pergi pada example 4. Show as well. Okay, example 4 dia kata, show that 5 to the power of n plus 2 minus 7 in bracket tu maksudnya multiplication here 5 to the power of n minus 25 to the power of times 5 to the power of n minus 1. Show that this one, the long one ni, nombor ni is divisible by 13 for all positive integers. Maksud dia dekat sini, apa maksud ayat ni? Soalan ni apa yang dia nak? Dia cakap yang ini, this one, the long one ni, this expression here, the long expression here is actually a number, one number. So this number, kita nak buat number ni sampailah kita jumpa nombor 13. Okay, itu adalah kita punya aim. Kita kena simplify this until you get number 13. So, dia kata show that this number, we don't know what is the number here, is divisible by 13. Boleh dibahagi dengan 13. Okay. Untuk itu kan teacher cakap tadi kan kalau kita nak simplify any indices, kita kena check dia punya base. Mesti guna base yang sama. So kita check kat sini. Okay, ni base 5. Cantik. Yang ni pun ada base 5 juga. Yang ni base 5. Yang 7 ni tak boleh nak buat apa-apa. Biar je dia sebab tak ada. There's no way you can express 7 in base 5. Okay. So sekarang dekat sini. Nombor 25 ni. 25 ni is actually you can express 25 ni in base 5, isn't it? Whereby 25 is actually 5 to the power of 2 dekat situ. Okay, so kita akan tukarkan dia kepada base 5. Okay, macam teacher buat ni. Okay, this is the questions yang asal. So this is the one. Okay, yang pertama ni, next lepas kita tengok yang itu, kita akan tengok yang tambah ni. Okay, tambah ni maksudnya menggunakan multiplication rule. So this one, 5, contohlah kat sini kan 5 power of n plus 2 ni, this is multiplication because of it is ada tambah. So dia akan jadi macam 5 kuasa n, dia akan darab dengan 5 kuasa 2. Okay, yang ini pula division. Kalau division kan yang the third one tu 5 kuasa n minus 1. So minus kat sini, minus ni maksudnya it is division. It will be 5 power of n divide by 5 power of 1. This is what I did here. Okay, teacher terus tukar. Teacher buat serentak terus kat sini. So first thing that what I did is I convert this 25 to 5 to the power of 2. Secondly, I'm using this multiplication and division law. Use base 5 for all terms. Kecuali 5 tu tak boleh nak buat apa kan. So kat situ. And then I'm using this multiplication law and division law to simplify this. Okay, it seems like I want to expand this. Okay, now kita pun tengok. Ada 3 terms. The first term here, you have 3 terms here. Okay, this is the first term. This is the second term, yang 7 dengan 5n tu. And this one is the third term, dipisahkan oleh minus tu. Okay, kat sini kita nampak apa yang sama, apa yang they have the common factor which is 5 to the power of n. This one pun ada 5 to the power of n. This one also 5 to the power of n. Whenever we have the common factor untuk semua terms, what we do is kita factorize it completely. Factorize completely means kita keluarkan 5 kuasa n tu. Okay, jadilah macam ni. When you keluarkan yang ini, apa yang tinggal adalah 5 kuasa 2 je. Okay, 5 kuasa 2, 7 saja. So nampak tak negative 7? And kenapa dapat negative 5? Because of I simplify 5 power of 2 dengan 5 power of 1 here. So you get 5 kan, isn't it? This one you get 5. Okay, now take a look. A closer look at this dalam bracket ni. Nampak tak? Dia nombor biasa dah ni. Ni kita boleh simplify je ni. 5 kuasa 2 is 25 minus 7 minus 5. Which is berapa? Which is 13. Ni adalah 13 sebenarnya. C is a magic. Kita dapat 13. Nampak tak apa kita nak buat cari tadi? Kita nak cari, nak jadikan dia sampai jumpa nombor 13. Kita sekarang dah jumpa nombor 13. Bila kita jumpa 13 tu maknanya kita boleh buat conclusion. This number is divisible by 13 for all positive integers of n. Okey, apa maksudnya cikgu tu? Tak faham lagi lah. Maksudnya macam ni. Contohnya, kalaulah teacher gantikan 5 tu tak kisahlah kuasa berapa. 5 kuasa 2. Sebab n tu adalah integer, positive integers kan. And then ini ada 13 kat depan ni kan. So this number, boleh tak kita divide by 13? Boleh tak kita divide by 13 without any balance? Tak ada. Boleh kan? Because we boleh simplify here. So you get 5 power of 2. You put any power here, which is positive 1. So you can divide it by number 13. Okay, that's how you do it. Okay, now next question. Example 5. Okay. Yang ini tak proving pula ini cari pula nilai. Kata kat situ soalan dia. 5 to the power of 6n times 9 to the power of 4n times 15 to the power of 2n over 3 to the power of 2n. It is equals to k to the power of 8n, where k is a positive integer. Find the value of k. This time kita nak cari value of k. Kita ada left hand side and we have the right hand side. Okay, right hand side tu dah cantik, which is single index number, isn't it? Single indices here, index notation number. So kita tak nak kacau yang belah right hand side, kita tengok yang left hand side here. We want to simplify this one. Remember teacher cakap apa? Kalau kita nak simplify, kita kena make sure yang dia ada base. Cuba samakan base dia. Kita tengok, kita check. The first one kat sini. We check dahulu. Okay, this one. 5, okay, cantik. Kat sini pun, ni 3, base 3. Tak ada pun yang sama. Ni 9, 15. Betul tak? Tak ada yang sama lah. Macam mana ni cikgu? So, apa yang kita perlu buat, kita tengok. Tapi, 9 ni, kita boleh express dalam base 3 kan? Which is 3 kuasa 2. Yang 5 ni definitely lah kita tak ada, we have no number whereby they multiply by itself, you dapat 15. Tapi hubungan dia dengan 3 dan 5 adalah, this one is actually 3 times 5. So nampak tak dia dah gunakan base 3 dengan base 5. Okay, kita tukarkan 9 dengan 15 tu dengan apa yang teacher tulis tu. So what you get is this one. Okay. The first one tu kita remain the same, which is 5 power of 6n. Okay, itu dah cantik. Kemudian yang ini, this one adalah 9 kan, kita tukarkan jadi 3 kuasa 2 4n. So this one adalah 15, 5 darab 3 which is 15. Power dia sama, the index is the same and denominator remain the same, nothing change. So what we did is, apa yang kita buat, kita menggunakan use base 3 and base 5. Okay, check. Dah guna use base 3 dengan base 5. Next, kita check. Kat sini kita nampak kan yang ini, darab dengan ini kita gunakan power law. Kita belajar tadi kan, maknanya 3, 2 darab dengan 4, 8n. For this part pun kita guna raising power as well. This one, dia kuasa 5 kuasa 2n. Yang ni pun akan jadi 5 kuasa 3n. Okay. You get this one. Okay, apabila teacher buat yang explain atas tu, so at the end you akan dapat 5 kuasa 6n, 3 kuasa 8n, 5 kuasa 2n, and then 3 to the power of 2n divided by 3 to the power of 2n. So sekarang kalau kita perhatikan, kita dah ada base 3 dan base 5. Cantik. So kita combine them together. Base 5 mestilah pasangan dengan base 5. Base 3 ada 2 operations there, where is multiplication and division. Darab dan bahagi, maksudnya kita akan menggunakan, kalau multiplication kita tambah 5, this one 6n kan, 6n mesti tambah dengan 2n. So you get this one lah, the first one untuk base 5. For base 3 you dapat 8 tambah dengan 3 and then minus 2 because of this is division. So kita gunakan this one, the rule is multiplication and division rule. So you using this one. So lepas itu kita buat apa? Kita pun simplify it. 6 tambah dengan 2, you akan dapat this one. 5 power of 8n times to the 3 power of 8n. Tapi sekarang ni kita tengok. Base tak sama kan? 5 dengan 3 tak sama. Tak bolehlah kita nak tambah dia punya ni, the index dia. So tapi cuba perhatikan. This whether the base is not equal but the index is equal, sama. So apa yang kita buat? Kita gunakan yang ini, the rule here. Bila base tak sama, index sama, kita boleh combine A and B. So 5 dengan 3 tu kita boleh darab. 5 darab 3 adalah 15 power of 8n, you akan dapat 15 power of 8n. Kita compare dengan k to the power of 8n tu. So you get this, hence by comparing, k is equals to 15. Nampak tak k? This is k power of 8n. This one adalah 15 power of 8n. So by comparing, you akan dapat k is equals to 15. Okay? Boleh kan? Now, itu adalah simplifying. Kita cuba tengok yang solving problems pula next. Okay, simplifying. So, again, simplifying lagi sikit. Expression ya. Okay, given that, example 6, given that P to the power of 3x and Q to the power of 3y. Okay, this one 3 to the power of x here using base 3. This one also Q using base 3 as well. So clue di sini. This is dia given you a clue. Kena tukarkan kepada base 3. So express this one 27 power of x plus y over 9x, 9 power of x in terms of P and Q. Meaning that you want to express this in terms of P and Q. No more x, no more y. Dah tak ada y, tak ada x. So apa yang kita perlu buat yang inilah. The first thing that you should do is 27 here kita express in base 3. Because why? Because we are using base 3 here. Clue dah bagi kan. So 27 is actually 3 kuasa 3. So power of x plus y. So for 9 pula ni, this is actually 3 kuasa 2. Kita convert that one. Use base 3 for all terms. Kita gunakan base 3 for all terms here. Next, what we do is, yang power ada raising power tu, this part, kita darab dia. Ni raising power ni darab dengan ni darab dengan yang ini. So dia akan jadi apa kat situ? 3 power of 3x plus 3y. So ada tambah, kita gunakan multiplication. So this one. So I'm writing this way first. So kenapa jadi macam ni tambah? Because of I'm using this multiplication rule here. Okay, because of ada plus ni, m when it comes to m plus n, kita boleh, it seems like you expand it. Expand it, it will become this one. A power of 3x darab 3, okay, this is 3. 3 power of 3x times 3 power of 3y. And then this one, they remain the same. Okay, so this part, kita nampak, kita compare dekat atas. Ni adalah 3x, tapi ini 3 kuasa 3 kan? This is 3 kuasa 3. Remember, 3x is actually 3 darab x. So you boleh tulis juga sebagai x darab 3 kan? Ingat tak 2 darab 4, 4 darab 2 kan? Sama je. So kadang-kadang budak form 1 pun, student form 1, dia akan tulis macam ni lah. Mula-mula dia belajar, dia buat macam ni, x3. Dia tak tulis 3x, dia tulis x3. So kita akan jadi macam tu kejap. Ya? So kat sini, instead of writing this way 3x, kita tulis dia sebagai x3 darab dengan y3. And then bawah ni pun sama. 3 to the power of x2. Okay, macam itu. Because kita nak samakan dekat atas ni. 3x, 3y ni kan express in terms of PQ. So teacher bagi nampak jelas lagi, teacher letak bracket here. 3 power of 3x and power 3, 3 power of y, power of 3 over this one 3 to the power of x, power of 2. So you akan dapat apa? Kita gantikan 3x tu dengan p and then 3y tu dengan q, you get this one. And tak habis lagi, kita simplify pula p dengan ni. P power of 3 dengan P power of 2, you get the final answer is PQ power of 3. Mudah kan? Senang kan? Okay. Next, kita pergi pada next questions. Kita nak solve problem pula. Number 7. Okay, number 7. Solve each of the following equations. Okay, solving. Solving means, okay, kalau kita nak cari solving means you have to find the value of unknown. Kalau nampak mana-mana perkataan dalam math, solve. Meaning that you have to find the value of x ke y ke, depends so much on questions. So how to solve this? Equations involving indices can be solved as follows. So first of all, you can express. Okay, kita expresskan dalam bentuk macam ini, first thing. Whereby the base sama, when you have this base, this form. And whereby the base is same, kita compare dia punya indices to index, whereby we can conclude that x is equals to y. If let's say the base is not equal, but the index is equal, so also you can compare the base, whereby base will be the same, a is equals to b. So yang itu yang kita akan tengok when it comes to solving. Okay, first kita pergi pada first questions. 2 to the power of 3x equals to 12 minus 2 to the power of 3x minus 1. Kita tengok kat sini ada base 2, this one also base 2. Macam it seems like it's a like term. Kalau like term normally dalam bahasa kasar kita kata kita nak letakkan dia pada bahagian yang sama. Or otherwise kita kata kita nak eliminate this, kita just add this one dengan benda yang sama, left and right. So you get this. It seems like you bring this over there. Seolah-olah kan. So akan jadi tambah kat sini. Okay. And then equals to 12. Next what you do is, kita buat apa? Ada tolak kat sini kan. So kita tak boleh nak selesaikan kalau ada kat sini, kita kena ganti. We have to write this one dalam bentuk division law. Kena gunakan division law here. So what you do is, kita gunakan division law whereby A power of M divided by A power of N, it is equals to AM tolak N. Okay, kadang-kadang because of teacher tak tulis kat situ, might be you get confused. This one, other than tulis macam ini, you boleh tulis macam ini. A power of M over A power of N. Sama je. It is equals to A M minus N. Bila kita nampak, every time you nampak minus je, mesti ada kaitan dengan division rule. So that's why I'm convert, instead of writing this way, I'm writing this way. Senang kan kat situ. Now, kita check kat sini apa yang sama. It seems like we have the common factor, which is 2 to the power of 3x. Nampak tak? Dia sama kan kat situ. Every time bila kita ada 2 terms ataupun how many terms ke, kalau kita ada common factor, kita factorize completely. Dah terlindung dah tu. Sebab teacher dah conteng situ. Biarlah kan kita fahami ni. Padam. Okay, kita factorize completely. It seems like kita take out the 2 to the power of 3 tu. 3x outside. So what is left is here. Okay, kenapa dapat macam ni? Okay, you want to check whether your answer is correct or wrong. If you expand this back, maksudnya you darab dengan 2 to the power of 3x multiplied with 1 here, you get this back. And same goes to this one. If you multiply inside here, you get this back. Okay, this is what we call as the factorization. Okay, once you factorize this, you nampak kat sini dalam. The inside here, you can simplify it. Whereby you get this what? You get 3 over 2. Okay. In order for you to eliminate this part, kita darab balik yang ini dengan 2 over 3. Okay. This one, you want to eliminate this one. Because we want to find the value of x here. Ini 2, kita darab dengan 2 over 3. We multiply this one. Also this one, left and right. Kita kena multiply dengan 2/3. Kat situ, automatically this part will be eliminated. So this one, kita simplify, you akan dapat 8. Okay, it is 8. So when it is 8, you know that 8 can be expressed in base 2, whereby 8 is actually 2 to the power of 3. Okay. Now, kita dah sama dengan yang kat sini. A ni, base ni. What you do is, kita compare the index here. Use base 2 for all items. You compare the index. 3x is equals to 3. So, x is equals to 1. By comparing the index kat sini. Compare kat sini dengan sini. Because base dia dah sama. So, you akan dapat x is equals to 1. So, kita pergi next example pula. Okay. This one pula. Involved in fraction. So, 8 times 4 to the power of x equals to 32 over 16 to the power of 1 minus 2x. So, bila dekat sini, okay, for this one, bila kat sini kita nampak, we want to eliminate this part. Yang bawah ni, maknanya kita multiply both side dengan benda yang sama juga, you get this. Okay, you multiply this with this one. And then at the moment yang this one also you want to eliminate 8 also, you divide it the both side dengan 8. So ataupun kita tukar, kita buat cross multiplication here. So you get this. Okay, kemudian we can see that 16 dengan 4 ni, 4 and 16 tu, 16 is actually you can express 16 in terms of 4, whereby 16 is actually 4 to the power of 2. Okay, kita boleh express 16 dalam base 4. And this one kita boleh eliminate, you get 4. 32 bahagi dengan 8, you akan dapat 4. So, obviously kita nampak kita menggunakan base 4 here. Semua base 4 kat situ kan? So, kita akan dapat use base 4 for all terms. Kita gunakan base 4 for all terms here. So, yang ini because of 4 to the power of 2. Okay, kita darab each element here. You get what? Because of this one adalah multiplication rule. Okay, kita tambah je. X tambah dengan 2x tambah minus 4x. This is 4 to the power of 1. What we do is, kita nampak yang ini base sama, right? Isn't it? Base sama. So when base is equal, kita just compare the index atas ni. So this one you simplify, you get what? 2 minus 3x. Okay, equals to 1. This is the base, this is the index actually. Okay, baru kita selesaikan. You get, by comparing index, you get x is equals to 1/3. Okay, this is example for you to solve the problems. So another one, the last question for indices untuk solving problem is this one. Example 8. In research, a type of bacteria will multiply itself in 1 minute. The amount of bacteria at start of the research was 300. The amount of bacteria after 30 minutes is given by 300. This is the formula given. It is 300 times 3 to the power of t. Okay, we are talking about the bacteria multiply itself in 1 minute. So the first question A, determine the amount of bacteria after 9 minutes. Okay, yang B, determine the time in minute for the amount of bacteria to be 70,900. Solution, the first question A. So you are given, this is the formula to find the amount of bacteria, which is B is equals to 300 times 3 to the power of t. Okay, and then dia bagi dah masa where time is equals to 9. When t is equals to 9, okay, kita just substitute the value of t, 9, into the formula here. So 300 times 3 to the power of 9. So you get this answer, 5,904,900. This is the amount of bacteria in 9 minutes, after 9 minutes. Itu maksud dia, ya. Now, we go to B pula. Dia nak time pula for the amount of bacteria to be 72,900. Time dia, bila masa ke berapa. So, what we do is, we use the formula here. Okay, this is the formula to find the bacteria. And then you equate it to this amount. So you get this one, 300 times 3t to the power of t, it is equals to 72,900. Now, we want to find t. First of all, this one, 300 is the constant part. We want to eliminate this. Kita divide both sides dengan 300 ni juga. Automatically 300 will be eliminated. So this one akan jadi 243. 72,900 divided by 300, you get 243. And then 3 to the power of t, it is equals to 243. So this one is actually dia dah bagi clue. 3, gunakan base 3. Base 3 kuasa berapa dapat 243 sebenarnya, itu maksud dia. So you have to convert this part, 243 dalam base 3, in base 3, ya. So you akan dapat 3 kuasa 5. Okay, 3 kuasa 5 is actually 243. So now you have the same base, you just compare the value of time there. So time is equals to 5. So you can make a conclusion that when the amount of bacteria to be 72,900 is after 5 minutes. Itu maksud dia. So this is basically the use of indices and then dia punya the use of indices dalam solving problems. Kita dah belajar dah, kita dah tengok dia punya law of indices semua. Now, kita pergi to the next topics pula, ya. Laws of Surds. Kita belajar Surds pula. Remember, kita ada 3 topics to be covered tonight. Okay, laws of Surds. Apa Surds ni? Before we learn Surds, kita pergi pada satu terms yang sangat is very important terms that you should know in Surds before you learn Surds. Okay, rational numbers and irrational numbers. Okay, what is rational numbers? What is irrational numbers? Kita pergi takrifan untuk yang ini dahulu. So, rational numbers. What is rational numbers? What are rational numbers? Okay, rational numbers tu adalah numbers can be written in fraction P over Q. Itu adalah rational numbers. Ingat tu, banyak yang dah lupa apa rational numbers, apa irrational numbers. Rational numbers is numbers that can be written in fraction P over Q, where P and Q are integers and Q is not equal to 0 definitely. If Q is equal to 0, dia dah jadi undefined. Okay. Okay, kemudian apa nombor dia? Apa contoh number rational numbers? The first one is integers. Semua integers, nombor bulat, nombor 6, nombor 13. Kenapa dia dikenali sebagai rational numbers? Because this one also kita boleh tulis dalam bentuk fraction kan? 6/1. 13 akan jadi 13/1. Dalam bahasanya, kesimpulan dia, all whole number are rational numbers. Okay, simpan tu. Kedua, apa lagi rational numbers? Kedua adalah terminating decimal. Terminating decimal tu apa maksud terminating decimal? It is decimal yang macam kalau kita tekan calculator dia cantik, dia tak ada ekor panjang-panjang tu. Macam 0.8 ni. This one is actually 4/5 ni. Okay, this one, because this one terminating decimal ni, you can express terminating decimal in terms of fraction sebenarnya. Cubalah ambil calculator, you tekan je lah. 0.3, 0.4, 0.25 itu semua akan jadi automatically fraction sebenarnya kalau gunakan calculator yang the latest tu lah, yang 2 tu. Yang hitam tu tak boleh rasanya. tak ingat dah. So 0.75 ni sebenarnya apa dia? Kalau tekan calculator, it is actually 3/4. Terminating decimal, all terminating decimal can be written in fraction sebenarnya. That's why dia adalah rational numbers. Ketiga adalah recurring decimal. Recurring decimal also is a rational because recurring decimal you can write in fraction sebenarnya. Okay, nanti kita akan belajar ni macam mana nak tulis ataupun guna calculator pun you boleh dapat fraction kalau recurring. Recurring decimal means what? This one number, recurring decimal ni dia berulang. For instance here, 0.2828. Sebenarnya ada dot-dot tu kan, maksudnya dia 28. Kalau dekat calculator tu sampai habis. Itu maksudnya recurring decimal. The same number repeated the same time. It's same again, the same. So and then this one pula 11. 11 tu memanglah tak repeat kan kat sini. Tapi nampak tak dia punya decimal tu? It is repeated. Nombor yang sama, recurring. 86 sampai habis. Okay, this one is actually you can write it in fraction. Itu maksudnya. Dalam erti kata lain, rational numbers tu numbers dan you boleh tulis dalam bentuk fraction lah apa yang dia cakap tu. Takrifan dia kat situ. Okay, now lawan rational numbers adalah definitely irrational numbers. Apa pula irrational numbers tu, teacher? Definitely lah irrational number adalah number in the form of non-recurring and infinite. Maksudnya infinite tu tak terminating lah, is not terminating decimal. Maksudnya dalam erti kata yang lebih mudah untuk awak faham, calculator tu bila you tekan nombor dia yang ekor dia panjang, tak berhenti. 1, 2, 3, 4, 5, 7, 9, semua tu calculator tu. So itu maksudnya non-recurring and infinite. Dia tak berulang-ulang dan dia tak putus. Tu maksud dia. Contoh dia apa? This one. Contohnya pi. Pi itu sebenarnya ada nilai dia kan. 3.142 panjang lagi lah semuanya. Okay, ada dot-dot tu maksudnya dia infinite. And then also this one exponent kan. Dia pun epsilon, sorry. 2.7182. This one actually dia pun bersambung-sambung ni. Dia tak recurring, dia infinite. Okay, itu yang decimal juga tu. Kemudian lagi satu Surd 13, Surd 5. Okay, ni kita dah selalu belajar dalam Surd kan, kita jumpa dalam Surd ni, sebenarnya kita dah jumpa masa form 1 pun, masa kita belajar numbers. So Surd 13, Surd 5, semua ni when you press the calculator, you get the infinite decimal, is non-recurring decimal. So yang ini yang kita akan belajar. So irrational number in the form of root. Surd tu adalah irrational number tapi in the form of root. Okay, in the form of root yang Surd lah simbol punca kuasa. Itu maksud dia. So kita cuba tengok contoh next one. Okay, kita nampak ni adalah contoh saja nak bagi you jadi lagi clear antara Surd dengan non-Surd. Number, the first one. Number kita letak Surd 3. Surd 3 when you simplify you get Surd 3 as well. When you convert it to decimal you get this one. Nampak tak? That one is the infinite decimal and is non-recurring. So it is, kita kenali dia sebagai Surd. Okay, the second number. Surd 1/4. When you, this one is actually square root of 1/4, you akan dapat 1/2, isn't it? Okay, ni kita dah biasa jumpa 1/2. When you convert it to decimal, you get 0.5, which is terminating decimal here. This is not Surd. Ni bukan Surd ya. So now kita pergi to the third one. This one kita panggil Surd 11 order 3. So this one, when you simplify it, you get the same thing. You tak akan dapat benda yang lebih kecil daripada ni. This is the simplest form, insert. So and then decimal dia akan jadi this one, whereby it is non-recurring and infinite. Nampak tak? Dia ada dot-dot-dot tu maksudnya dia panjang lagi lah tu. So this one is Surd, definitely. Because dia kan, Surd tu maksudnya Surd tu is a decimal yang tak cantik sebenarnya. Tu bahasa kasar dia. Okay, next kita pergi cube root 27. Okay, kita panggil ni cube root, right? So you get 3, isn't it? Kalau you simplify the number. And then when you convert it to decimal, you get 3 as well. So this one is not Surd. Okay, dia ni bukan surd. And the last one, this one, surd 3 order 5. This one also, when you simplify the number, you get the same thing. You takkan dapat nombor yang lagi kecil daripada ni. So, and you convert it to decimal, you get this 1.2457309 ... It is infinite and it is non-recurring. So, this one is definitely surd. Okay, now, itu faham ya kat sini, kita dah faham dah surd. Oh, itu maksud surd, itu maksud irrational. It is irrational ya. So extra input here. Kadang-kadang kita kan tak tahu nak cakap ni apa kan. Kalau yang ni kita katalah kan square root of 3, square root of 1/4, yang ni cube root. Kalau yang ni nak cakap apa ni? 5 root kan ni, 5 ni. So cara disebut dia adalah kalau macam ni kita sebut sebagai surd x order n. Kalau macam ni maksudnya surd 5 order 3. Itu kita sebut dia. Yang ini surd 3 order 5. This is how you sebut dia. Okay, student semua. Kadang-kadang student pun tanya, teacher ni macam mana nak sebut ni? This is how you sebut dia. Surd 5 order 3. Okay, next. Kita pergi pada example. Okay, example untuk recurring decimal. So, macam mana kan, memanglah kan kita boleh kata recurring decimal ni, if you use your calculator, you just press the number kan, you press the number kan, you press the number 0.29292929, definitely, and then you press the equal sign, definitely you can get the answer directly. The fraction, I mean the fraction tu. Tapi we want to know the process. How? You have to show the process kan. Kalau lah soalan dia tanya nak process, mesti you have to show. You cannot use a calculator. So first thing that you should do is kita express dahulu. Let n is equals to 0.292929 and remark here as the first enam tujuh. Kan ada 3 digit kan? 5, 6, 7. 3 digits repeating. So when it is repeating, 3 digits repeating, kita multiply dengan 1000. Kalau 4 digit repeating, kita multiply dengan 10,000 and so on. Macam itulah caranya. Kalau 1 digit repeating, kita just multiply dengan 10 only. Okay, so for this one, so kita remark this sebagai the second equation. Now what we do is kita 2 minus 1. Second equation minus first equation. So you get maknanya 1000 minus 1. That's why you dapat 999 n. So it is equals to this one. Again, the echo one after the decimal tu, it is being eliminated. Hilang semua. Yang tinggal adalah 5, 6, 7. So you can express n is equals to 567 over 999. You haven't answered the whole questions yet. So kita pergi pada yang ni lah. So A is equals to 13 tambah dengan n yang U ni. So you get this one is a mixed number. Thus 13.567, 567 and so on. It is equals to in terms of mixed number 13,567 over 999 in mixed number. Can write. Easy, right? Now next kita pergi pada simplifying the surd. Okay, ada sedikit laws of surd. Simplifying expression involving surds pun kita nak simplifying dia. Okay, ada 2 laws of surd. Simple laws only. So law 1 dengan law 2. Always law 1 tu dekat indices ke logarithm ke mesti darab. Kalau second law tu mesti bahagi kan. Kita nampak pattern tu macam senang you nak ingatkan benda tu. So kalau law of surds ni, law 1 ni, kalau surd A times surd B here, whereby A dengan B tu dia might be you cannot find the way, definitely when it comes to surd, definitely you cannot express it in whole number, isn't it? So you can combine them, it will be A times B dalam satu rumah yang sama. It seems like that one. So kalau yang untuk yang bahagi pun sama, division law pun sama juga. So you just divide here like this. Kalau when you have this surd A divide by surd B, you can combine them together, A over B, surd A over B. So kita tengok the first one, 50 ni, surd 50. 50 ni is not the simplest form lagi ya. Kita boleh express 50 tu macam inilah, 25 darab dengan 2. Perfect square darab dengan 2. 25 is a perfect square. Why? Because it is 5 square. So that's why dapat 25, right? So from here we are using this the first law here. Okay. So kita pisahkan dia kan macam ni, right? This one. So at the end you akan, because this one at the end the first, kalau you guna calculator directly you will get the answer. Tapi we want to know the process in this case. So 25 is actually 5. Okay, surd 25 is actually 5. So you akan simplify it, you get 5, surd 2. This is the answer. Okay, instead of writing this way, you have to write it in this way. You kena tahu buat benda-benda ni ya, untuk menjawab soalan yang seterusnya. We go to the second one, B. 98P ni, divide by. So bila divide kan, kita combine them because you cannot find surd 98 tu tak boleh. P pun you cannot find. You cannot write it in simplest form. So what you do is you combine them. Instead of writing this way, you write it this way. So you combine them together, you get this. And definitely you boleh simplify this. P dengan P, 98 divided by 2, you get 49. Okay, this one isn't it? You gunakan division in law 2 ni. So you akan dapat 49, and whereby 49 ni definitely you know what is the answer, which is 7. So instead of writing this way, is a very long expression here. You get this simplest form here, which is 7. Okay, this is how you one off. This is untuk darab dengan bahagi. Macam mana pula kalau melibatkan tambah tolak pula ya? Kita tengok pula next one. Example 11. So kalau when it comes to tambah tolak dekat sini, so surd M surd A plus or minus N surd A as well. So A, ni surd A ada 2 sama kan? So you can combine M dengan N2 together. Because you have, it seems that you have this, imagine that this one is X. You substitute the surd A ni jadikan X. So dia akan jadi macam unknown, isn't it? So you get M plus or minus N in bracket times surd A. Okay, tengok example 11, simplify this. So 9 dengan 7, 9 surd 7 minus 2 surd 7. Nampak tak yang ni? Surd. So maknanya kita combine 9 minus 2 kat sini. So this one nampak 7, 7. It seems like you factorize it. So maksudnya you akan dapat 9 minus 2, 7, surd 7. So you get 7 surd 7. It's a very simple one kat sini. Okay, boleh kan kat sini? Macam kita factorize yang tadi awal-awal tu, kita cari what is the common factor, take out it. Untuk yang surd kita letak dekat depan dekat sini, tak kisah. So now kita pergi yang B pula, expression. So 32 is actually quite big number. Kita boleh express dia dalam bentuk lain kan kat sini. So 32 tambah 32, this one kita boleh simplify, bukan kita boleh pecahkan lagi. It's actually how to get 32, it is 16 times 2 sebenarnya. 16 times 2, perfect square. 16 is the perfect square times 2. Tambah dengan 3 surd 2. So we use this first law, remember first law of this surd. Okay, kita boleh combine them, kita asingkan dia. Instead of here, kita asingkan 16 dengan 2 tu. Because we can find the value of surd 16 here. Square root of 16. Square root of 16 is actually 4, isn't it? 4 surd 2. Tambah 3 surd 2. So in this case, kita nampak we have 2 factors here. Common factor 2, surd 2, surd 2. So kita boleh, what we do is kita just add 4 and 3 together. So akan dapat macam ini, 4 tambah 3, which is 7, surd 2. This is the final answer using this one. Okay, this is kalau kita menggunakan yang tambah tolak tu. Okay. Okay, this simplifying saja. Ini kita saja nak simplify before we go to rationalizing yang paling yang penting lah kat sini. Okay, now next kita pergi example 12. Simplify the following expression. Yang ni pula. For this one, okay, yang ini kita simplify, kita darab, kita gunakan this one ya. Okay. First of all, you just expand this. Kita darab je semua ni. Okay, kat sini okay. Ada okay kat sini. This one, when you simplify this, first of all, you just expand the bracket. Darab je. 3 set n. Okay, for this one, you just multiply it together lah. 3 set 6 times set 6 because outside here is set 6. When you expand it, you get this, the first term here. And then minus this one. 5 set 6 times set 6 because you expand it. You expand kat sini and then you expand kali kedua dekat sana, right? Kat situ. And then you are using this. Kemudian kita tengok dekat sini. For this part. Okay. This part you nampak kan, this one. This one adalah set 6 times set 6. So take a look at the pop-up here. Whenever you have the set A times set A, automatically you akan dapat A. Okay. Kalau kat sini adalah set 3 times set 3. So automatically you get inside here only. It is equals to 3. So same goes to this one. Set 6 times set 6, you get 6. Set 6 times set 6 also you get 6. So kedarab sahaja kat sini 3 darab dengan 6 which is 18 minus 5 darab 6 adalah 30 and you get the answer is negative 12. So kenapa smart tips. Kenapa set A darab set A is equals to A? This is explain why it is A. Okay, remember kat sini kalau set ni is actually kalau kita tukar kepada fractional indices, this is kita panggil sebagai fractional indices. Ya. Yeah. Akan jadi A power of 1 over 2. This one also A power of 1 over 2. What we did is, kita tambah because of kita gunakan multiplication rule here. So tambah dia akan jadi 1. Nampak tak? So this is tips there. Why it come out like this. Okay. So now, this one pula. Yang B tu pula. For part B, here kita nampak ada 2 bracket expanding the bracket. Okay, this is expanding bracket. Macam ni lah kita belajar kan. Macam mana kita belajar expanding the bracket. Multiply this with this one. 9 darab 3. Yang ini pun darab dengan kat sini. So that's why you dapat 9 darab 3 adalah 27. 9 darab dengan 5 adalah negative 45. Negative 5 here. So the next step is here pula. Kita darabkan kat sini. And then another one is darab kat situ pula kan. So 5 darab 3 you dapat 15. And 5 times negative 5 you get negative 25. 4 semua tu. Why 4? Because of set 4 times set 4. You get 4 here. Okay. Now this part pula. Nampak tak yang ini? The one that I combine here. This is a like term. Like term, remember kita gunakan yang tadi tu. Yang addition and subtraction punya law tu. So 4, kita combine them. Negative 14 plus 15. Set 4. For this part, definitely 100 lah. Minus 100. And then this one 27. So this negative 100 and 27, we can combine them together. Okay. Get this. 27 tolak 100. And then minus because of negative 45 plus 15 is negative 30. Okay. Dapat yang ini. Okay, simplify. You akan dapat. This is the final answer. Okay, this is how you simplify the set one off. Apa yang penting adalah penggunaan yang ini, the smart tips here. Also this one. Apa yang kita belajar kat sini lah yang tambah dengan darab tu. Itu yang you perlu tahu, kena mahirkan diri you. Okay, next. Kita pergi pada next question. Next one is rationalizing. Rationalizing the denominators for expression involving surd. Apa maksud rationalizing? Macam ni ya, benda yang mudah sekali. Kalau kita ada fraction whereby the denominator tu ada surd. So kalau kita ada fraction whereby the denominator tu ada surd. So kita tak nak denominator tu ada surd, contoh macam A over surd B. So kita tak nak ni, tak nak bawah tu ada surd. So kita kena buat apa? Kita kena rationalizing it, denominators tu. So kita mesti bawah kita tak nak ada surd. Itu aja sebenarnya apa yang kita nak tahu kat sini. So ada 3 benda kat sini. The first one, kalau dia bentuk dia macam ini, tak ada plus minus, kita multiply, kita panggil dia sebagai conjugate. Multiply the numerator and denominator of this one, the fraction ni, with the conjugate yang ini. Ni conjugate dia yang ini, nama dia conjugate. Kita multiply dia dengan dia punya conjugate pasangan dia. Tapi dia panggil conjugate kat sini. So kalau you ada this time or this form whereby dia punya denominator tu plus kat sini, ada it's quite complicated here, kat sini ada plus, so dia punya conjugate will be minus. Okay, the same number here, the same value, but the difference is the sign here, satu plus satu minus, and vice versa. Kalau yang kat sini minus, so the conjugate will be plus. So kita tengok dia punya ringkasan. Kalau surd dia adalah M surd A. So kalau in this part lah, there is no plus minus here. The conjugate also akan jadi benda yang sama. So kalau surd dia adalah plus sini, yang whereby the value here is same, M surd A, and then this one also M surd A, tapi the difference is only for the sign here, plus minus. Same goes to this one, versa. Vice versa, kalau yang ini negative, this one will be positive. Okay. Apa yang kita akan guna, the first one, you kena mahirkan dekat sini. Kalau surd A times surd A, it is equals to A itself. And then this one adalah yang inilah. Kalau A, you just A, you can see clearly kat sini kalau A dengan B ni sama kan. Yang beza cuma plus minus ini saja. So automatically you just square A here and this one will become B. Just remember this only. So A square minus surd B square, surd B square, so you get B. So this is, you have to use this a lot. You akan guna benda ni banyak kali. So kita pergi pada example dia. Simplify the following. 5 surd 3. 5 surd 3 yang ini yang tadi yang kita nampakkan yang pertama tu kan. So 5 surd 3 ni kita kena darab. Dia punya conjugate adalah the blue one. You just multiply the numerator dengan denominator dengan conjugate dia. So surd 3, surd 3. So this one 5 darab dengan surd 3, you akan dapat multiply with the conjugate surd. So this part, surd part ni you get 3. So this one you akan dapat 5 surd 3 over 3. Because this one when you multiply it together you get 3. So this one, this is the simplest form that you can write it. Okay, itu yang pertama. Yang kedua, we go to B, question B. Remember this one, dia punya bawah tu denominator you have surd here. So this one adalah minus. Remember the conjugate will be plus. Okay, you get this one. So the blue part is actually the conjugate. You multiply with the conjugate whereby instead of minus it will be plus. Okay, and then kita darab macam biasalah kat sini we just expand it. 7 times 2, 14. 7 times surd 5, it is surd 5. So you get this. 2 power of 5, it is 2 square minus 5. 4 minus 5, you get this negative 1. Okay. Do not give your answer this one. Ni tak habis lagi ni. Kita kena bagi the ringkas one. You get the final answer will be negative 14 minus 7 surd 5. Okay, this is the final answer. Do not give your answer because of this one kan kita boleh simplify lagi. Okay, now how about this one? Kalau kita ada plus pula. Kalau ada tambah, so you akan dapat, you have to multiply with their conjugate which is negative. Tolak kat situ. So, and then kita simplify, kita darab, you akan dapat this one, you have to multiply each element here dengan kat sana. So you akan dapat this one, this part, surd 3. Surd 3 darab dengan surd 3. Remember, kita gunakan this part kan? So you akan dapat 3 tolak 2 which is 1. So final answer you akan dapat 6 minus surd 2. This one because why kita gunakan this one kan kita combine kan kita gunakan yang ini hukum ni combine them. So 3 darab 2 combine in one house you akan dapat 6. So 6 minus 2 to the power of 2 sub 6 sorry. Okay. Now next kita pergi pada this one rationalize this part. Okay, yang ini ada denominator and simplify. So akan dapat macam ini, you simplify this 3 and then this the conjugate here adalah this one is minus set dia and then you just multiply with the conjugate which is plus here. Okay, and kita pun multiply dia dekat atas tu you just expand it. Okay, you akan dapat multiply with the conjugate set. So you akan dapat kat sini because of 5 times 3 times 5 it is 15 and then 3 times set 5 you akan dapat 3 set 5 and 5 set times set 2 here you akan dapat 5 set 2 and this one another one is 2 darab dengan set 2 times set 5. This one you can combine later on. So you akan dapat this one. So this is the final answer. Apa kita gunakan apa kat sini? This one yang 10 ni because we are using this one. Formula yang di sini kan kalau set 2 ni kita boleh combine. For this part tak boleh nak buat apa-apa dah. Because they are unlike term, you cannot combine them. This is the simplest form that you can get. Okay, now kita pergi pada solving problems involving set. Okay, example here. The diagram on the right shows a pyramid shaped house, the triangle shape at the front house as the area. Okay, pyramid ni dia ada area adalah 20 set 3 minus 4 and the length of base adalah this one. Okay, dia kata determine the height of the triangle at the front of the house in the form of A plus B set 3 where A and B are rational numbers. Okay, first of all kita tengok solution dia macam mana yang dia bagi pyramid, dia bagi area and dia bagi the base. So like this, you are given the base here and the height we don't know where we have to find it and you are given also the area. Area of the triangle is given by this one 1/2 times base times height and then this is the base, this is the area given. Okay, kita masukkan dalam formula 1/2 time base time height. You equate it to the area given here. So you get this right. Okay. And then this one, you akan, for this part, you want to eliminate this. You just multiply the both side dengan 2. So you akan dapat 40 set 3 minus 8. So because you have to, you eliminate this part 1/2 here. Okay. Now, for this part nak cari at H ni, what you do is you just multiply both sides, you divide it by both sides dengan this part. Because you want to eliminate this, so kita bahagikan dengan benda yang sama. So that you can be eliminate here. So ini pun sama juga, automatically you akan tinggal H saja, right? So now you can see that this one haven't finished yet because your denominator ada set. What we do is kita multiply this dengan dia punya conjugate which is 4 set 3 minus 4. This is dia punya conjugate. Multiply with the conjugate set. Multiplykan dia. So you pun simplifykan dia. You multiply it. Each element here dekat dalam ni semua dengan sana. So you akan dapat 1603 minus this one. And then you tolak. This one you just multiply by macam biasalah kan kita expand the bracket actually. For this part pula yang ni nampak tak? 4 set 3 darab dengan 4 set 3 you akan dapat, why do you get this? Because of this one. Yang this part. So 4 set 3 times 4 set 3. So 4 times 4 you get 16. So set 3 darab set 3 you dapat 3. That's how I explain this one, why you get 16 3 ni. Untuk for this part, 4 square, you got 16. So, and then you simplify it, you get this, 512 minus 192 set 3, you divide it by 32, you get the final answer. H is equals to 16 minus 6 set 3. Okay. Next question. Also application of indices, surds and logarithm as well. Untuk yang ini. So you get you are given this carpet with a rectangle shape. Length 1 plus surd 5 and area is 80 cm. Calculate the width of the carpet in cm and express your answer in terms of A and B, where A and B is the value that you have to find. Okay, first of all, kita tengok carpet bentuk dia rectangle and you are given the area and also the width which you don't know, you have to be found here, and you are given the length here. Area dah bagi. So kita tahu area adalah 80, surd 80, given surd 80. And to get the area is just multiply 1 plus surd 5 darab dengan W. With dia, you get equal to 80. So you want to find this W with ni, you have to eliminate this part. So divide it by this part as well so that it can be eliminated. So W is equals to 80 over 1 plus surd 5. So this part kan denominator dia adalah surd. We want to we don't want that denominator to become surd. Multiply with the conjugate. Okay, multiply with the conjugate. Then what you get is you just expand this atas dengan atas kat sini, you akan dapat yang ini. This one will be 1 minus 5 because of 1 square minus square of surd 5. You get 5. Okay, next. You simplify this part, you get this. Okay, this one is actually 80. You can express in terms of this one. 16 times 5. Okay. Whereby this one actually you boleh simplify lagi. You akan dapat 4 surd 5 minus 20 over negative 4. And you simplify this part. You get finally you akan dapat macam ini. You compare with this A plus B surd 5 too. Okay, you write it in this way. And then you can conclude that A is equals to 5, B is equals to negative 1. Okay, 2. That is a surds that you have. Okay, this is the surd. It's all about surd. Now, next. Kita pergi pada the next topics, the last topics lah I think is logarithm. Laws of logarithm. This is unit 3 of 4.3, laws of logarithms. Okay. Apa pula laws of logarithm is actually the inverse of indices actually. So kita tengok laws of indices. Relating the equations in index form with logarithmic form and determining the logarithmic value of a number. Okay, apa dia punya explanation? For a positive number, A is not equals to 1. So this is, you can see this is the index number yang kita belajar tadi. A to the power of X is equals to N. You can convert it to log, whereby you tulis dia sebagai log base A. Okay, you nampak kat sini kan, log base A. This is base A kat sini. Log base A N. So this is index dia. Equals to the index. Log base A, bawah ni mesti base. This is index. So this one is actually A X index dia. So A to the power of X equals to N. Macam tu kan. A power of X equals to N. We boleh convert it. From index number, you can convert it to log. And from log, you can convert it to index number. Kena tahu kemahiran nak convert kan. If you are given the index number, you are asked to convert to log. So you kena buat macam inilah proses dia. So the first thing, kita tengok example dia. Convert the following to logarithmic form. Convert the following to logarithmic form. So the first question, A. Kita tengok the first one here. This is the base. This is index. Dua tu index, this is the base. Nampak tak yang kecil tu adalah base kan? So kita boleh tulis dia sebagai apa kat sini. So this is base. This one is index. So how to write it? Log base kan, log base 6, 36 ni kan index. This is base, this is index. So nampak, this is how you write it. Instead of writing dalam bentuk index, kita boleh tukarkan kepada bentuk log. Okay, base dengan index. So for the second one adalah yang ini. So log x log x is equals to y power of 3. So yang ada index tu adalah base lah, ada base. Yang ni adalah, which one is base? This is the base. This is base. Faham kat situ So this is index. So mesti sama dengan index kan? So maksudnya log base y 10x equals to index equals to 3. Betul tak? Okay, log base y, okay, 10x ataupun kita sebut sebagai log 10x base y equals to 3. So nampak tak? This is base, this is index. Dia macam cross kan kat situ. Dia pergi sini, y kuasa 3 is equals to this one. Nampak macam itulah lebih kurang. So this is you convert the index to logarithmic form. So how about converting logarithmic form to index pula? Macam mana? Macam tu juga. Ya. Convert the following to index. Ni dia bagi yang ni pula. Remember nampak tak yang ini kita bagi tahu tu kan? Bulatkan. This is base. This is index. So 8 kuasa 2 sama juga 64 lah. Macam tu je. So you akan dapat 8 power of 2 equals to 64. Base power, this is index dia, will be 64. Okay, yang ini ke sini. So it is equals to 64. Go to the second one, B. This one. This is the base kan, yang kecil tu adalah base. Log 1 over 1000 base 10 equals to negative 3. So this is index. So you akan dapat apa? 10 to the power of negative 3, it is equals to 1 over 1000. This is how you convert the index to log or log to index. Okay. Kita pergi pula relating dia. Kita kena tahu nak convert dia. Kita baru nak convert, nak simplify dahulu. Okay, 19. Convert 2 to the power 2 equals to 5 power of m. Convert this. Okay, convert this part and this one to logarithmic form. Hence, express each of the following in terms of m and on. So, ada dua soalan yang kita kena jawab. The first one is kena convert dahulu. The second term, kita kena jawab soalan ni. Okay, first thing nampak, this is the base, this is index. So, kita convert first. So, 2 equals to 5m. This is index form. Kita convert to log. It will be log base 5, log 2 base 5. It is equals to m. Yang sini, yang belah kanan ni sentiasa dia punya index lah sebenarnya. This is index. Kalau kita tak tahu nak tuliskan, kita buat je dulu. Sama juga dengan apa index dia? M. So m. So yang ni base adalah base 5. So yang ni letaklah 2 number tu. Okay, now you dah convert. Kemudian kita pergi yang ini pula. This one maknanya log 3 base 7 equals to n. Betul tak? Log 7 base log 3 base 7 betul lah equals to n. Isn't it? Because of base dia mesti kecil kat situ lah. So you dah convert. You have answered the question here. Okay, check. So kita jawab soalan yang ini. Log 2, log base 2. Okay, this one kan kita convert. Okay, now kita jawab soalan yang ini dahululah. So log 2 base 5. Ada tak log 2 base 5 here? Ada kan, which is m. This is m. Okay. This part pula, remember, kita dah belajar ni, log n is equals to 1 sebenarnya. This is 1. And this part pula, log base 5 1 is equals to 0 actually. This one, because of 5 power of, remember this one, 5 power of something equals to 1. It is 0. Okay. This part is 0. This one adalah 1. Log base n is 1. Log base n kalau 1 je kat sini equals to mesti 0 jawapan dia. Apa saja base kat sini. Yang kita mudah-mudahan kan. So now kita dapatlah kat sini. So kita tulis m tambah 1 tolak kosong because this is 1, this is kosong. So you akan dapat, tak payahlah tulis kosong tu. Kita akan dapat m is plus 1, the answer. Kita pergi the second one pula. This is slightly direct question saja. Log base 7 3. Which is what? N. And this one adalah log 2 base 5 adalah m minus 10. So dapat macam tu je. This is direct questions only. As long as you know how to convert this one first, definitely you can answer this one. Okay? Now, kita pergi pada, nak pergi tengok dia punya laws of logarithm pula. Okay. Laws of logarithm. Inilah notes yang tu kenapa dia kosong kat sini lah. Since A power of 1 adalah A, so that's why dia dapat 1. Ni explain why ini adalah 1. This one explain why ini adalah kosong. Because A kuasa kosong, ini kita dah proof tadi kan 1. So meaning that log base 1A is equals to 0. Explain here. Next, kita pergi pada proving product law. Okay, product law kat sini. We have 3 laws of logarithm. Okay, first law, second law, third law. First law is something to do with the multiplication. Nampak tak? X darab Y. Bila kita, it seems like we want to expand this, you akan dapat log AX, log X plus log Y, base A, both. Untuk division pula, always minus, isn't it? So log X over Y, base A will be log X minus log Y, base A kat situ. And then another one, you have the power law pula. Log X power of NA, yang ni dia akan jadi N tu, it seems like you bring over there. So akan dapat N log X base A. So how to prove that? Kita tengok dekat atas. Let X is equals to A power of P, Y is equals to A power of Q. Kita determinekan ni, kita buat dia punya takrifan kat sini. And then from here, kita jadikan dia, kita tukarkan kepada logarithmic akan jadi P is equals to log AX and Q is equals to log AY. This is from this definition of logarithm. Kita when convert logarithm to index and index to logarithm. Okay, logarithmic form. So from here, apa yang kita nak buat? Kita nak proofkan product law ni. First thing kita XY. XY, kita substitute X dengan A power of P, Y dengan A power of Q. So XY is equals to AP times AQ. From here, we are using the multiplication law of indices, akan jadi A, P plus Q. Nampak kan? Kat sini kan kita gunakan ini. And from this part, kita convert it to logarithmic form. It will be log base A, XY equals to P plus Q. Nampak tak? Log base A, XY equals to P plus Q. Yang ni yang kita buat takrifan tu kan. So now barulah kita tulis yang P tu tadi apa? P is actually log base A, X, and then Q adalah log Y base A. So that's why kita proof lah. We prove that this one adalah yang ini. This is how you prove it. Proving is very important now. Dalam DSKP, you have to prove this one. Okay, now kita pergi pada division law pula. For division law, first of all, you just write X over Y first. So, and then kita gantikan X dengan A power of P, Y dengan A power of Q, like this. Then, kita gunakan, we use the division law to get this. So, using the division law, because of base sama, so meaning that P minus Q. Okay, this is why you get this one. Kita dapat kan, X over Y adalah A, P minus Q. Then, from here, we have to convert this to logarithm. Log base A XY, it is equals to P minus Q kan, index dia. Mesti sama dengan index. So, what we do is, we just substitute back the value of P, which is log AX. And then Q adalah log AY. So, that's why you dapat yang proof kan. Log XY, X over Y is equals to log AX minus log AY. Okay. So yang the last law pun sama juga. Kita buat X power of N. So substitute the value of X as A to the power of P, power of N. From here kita gunakan power law, which is X power of N is equals to A power of Pn. Okay, from here kita gantikan, kita convert it to logarithmic form, which is log base A, X power of N equals to Pn. Okay, ini adalah takrifan untuk logarithmic from indices to logarithmic. So from here kita nampaklah kita just gantikan saja Pn is actually what? Is log AX darab dengan N. So proofkan semua dia punya laws of logarithm. Kita pergi pada simplifying this one. So sekarang now we are going to use these laws to simplify the logarithm. Tergeliat lidah teacher nak sebut logarithm ni. Okay, we go to example 20. Okay, dia bagi kat sini dah kan. Log 2 base A is equals to 0.2 558 and log 7 base A equals to 1.206. Find the value of each of the following. So the first one, log A, log 28 base A. 28 ni kita kena kaitkan, dia ada gunakan 2 dengan 7 kan. So 28 is actually 4 times 7, whereby 4 is actually 2 to the power of 2. So gitu kat sini. Log A is actually 7 times 4, isn't it? Okay, kat sini kemudian nampak kan darab. Darab tadi kita gunakan apa? Multiplication law of logarithm. So maksudnya kena tambahlah log A 7. Ni kan, yang ni kan dia punya law tu yang pop up ni. So because of darab kita jadikan tambahlah kat sini. Log A, it seems like you want to expand this. This is how you expand the logarithm. Bukan expand macam cara biasa yang log A7 darab log A4, 4, salah. Bukan macam tu. This is how you expand it. So this one, and now log A7 kita dah ada dah. Log 7 base A which is 1.206 kan. So yang ini pula, yang ini apa dia? Ni tak ada pun, ni adalah 2 kuasa 2. So tulis sebagai 2 kuasa 2. So yang ini kita gunakan logarithmic tadi, 2 ni kita letak ke depan kan. Kat sini you akan dapat macam ni. 2 log 2 base A. Okay, because of we are using the power law here. So baru kita gantikan, masukkan nilai. Yang ni adalah 0.558. So selesaikan, you akan dapat 2.322. Okay, kita pergi pada the second law. Ni melibatkan division law. Nampaklah obviously, isn't it? Ni senang je. So log 2 over 7A. Okay, ni kita gunakan apa? Kita gunakan definitely division law kat sini kan ni. Kita guna, this is the division law, the blue one tu. So kita just minus lah log 2A minus log 7 base A. So gantikan saja nilai-nilai ke atas tu. You get this one 0.558 minus 1.206. You get the value of negative 0.68648. Next, the last one. Kita bukan last question, so last untuk yang ni. So log Surds 7 order 3, okay, base A. So yang ini kita tukarkan dalam bentuk fractional indices. Okay, this one bukan, ni tak boleh nak selesai lagi. Tukarkan dalam bentuk fractional indices kan, which is 1 over 3. Tadi kita dah terangkan sikit kan fractional indices tu. So from here yang ini kita gunakan power law, letak ke depan tu, macam kita letak ke depan tu. So you akan dapat yang ni lah, 1 over 3 log 7 base A, whereby yang ini kita tahu value 1 over 3 darab dengan 1.206. Simplify it, you get 0.402. Okay, senang kan? Now next, kita pergi to the next question. Example 21. Express the following as single logarithms. It is very important for us, very crucial for us to change to express the log in single logarithm, sebab kita nak, whenever we want to solve something, kita kena solve the logarithm, normally kita akan jadikan dia single logarithms, right? So for instance, the first thing that you should check is the base of the logarithms tu. Kalau sama semua kan, ni tambah melibatkan darab, this one melibatkan bahagi. So what you do is, this one, you write it first, okay, and then kita nampak base sama. Kalau tambah maksudnya darab, 5 darab dengan 8. And then tolak maksudnya bahagi dengan 4. So you akan dapat macam ni lah. Because of darab ini senang je because base dia sama, right? So 5 times 8 divide by 4 because why? We are using this law. Okay, kalau law kat sini, right? So kalau tambah maksudnya kita combine them, you get darab lah, dibahagi. So for this part kita boleh simplify, you get 40 over 4 which is log 10 base M. Okay, ini simple je. Okay, for this part pula. Now kita pergi pada second questions. 1 over 2 log 4 log x base 4 and then tambah 2 tolak dengan 3 log y base 4. Kat sini kita check, okay, ni ada log, ni pun ada log, tapi this part tak ada log kan. Okay, bila tak ada log kita kena make sure semua ada log. So apa yang kita perlu buat, yang kita ingat, kalau ingat tak yang log base n Do you remember this yang ni? Kalau log base A it is equals to 1. Ini kita akan gunakan benda ni. So it could be any base here actually, any base. Okay. So apa yang kita buat kat sini adalah kita darabkan, kita logkan yang itu, bukan kita logkan, kita darabkan dengan apa? Kita buat macam ni. So this one kita gunakan power law, kita naikkan dia dekat atas so that dia akan jadi single macam ni. Log x power of 1 over 2 base 4. For this part yang the blue one ni, this one is actually nilai dia 1. Tapi teacher just letakkan kat sini because kita nak combine them. So each element should have log. So this one is actually 1. Okay. So tak ada apa-apa lah kat sini kan. So baru kita boleh combine. Okay. And then 2 ni kita naikkan ke atas akan jadi 4 kuasa 2. Like this. Okay. This one. Gunakan power law. Baru kita boleh combine them. Kalau tambah maksudnya darab. Tolak maksudnya bahagi. So you akan dapat this one tambah dengan bahagi. So you combine you akan dapat log x square and then darab dengan 16, isn't it? This is 16 and then minus over dengan y over 3 kat situ. So 16 ni sepatutnya letak kat depan lah ni, kat sini kan sepatutnya 16 x power of 1 over 2 over y kuasa 3. Okay, next question. Again, kita still guna laws juga ya. Nak simplify dahulu. Ni semua simplify je dahulu. Ada lagi ni. Okay, given log A, log 5 base A equals to P, log 3 base A equals to Q. Express each the following in terms of P and Q. Okay, first of all yang ini, 5 dengan 3. Basic dia kan maksudnya 5 darab 3. Okay, apa yang kita buat kat sini, first thing adalah this one 15 is actually 5 darab 3 kan kat sini. Ataupun 3 darab 5. So this one is actually because we want to use this information to get the P and Q. So kita tulis sebagai log 3 darab 5 base A. So because this one later on kita akan gunakan multiplication law dia. Kat sini darab maksudnya kita akan pisah, kita akan expand dia akan jadi log base log 3 tambah log 5 base A. So this one is actually Q, this one is P. So dah answer lah in terms of P and Q. Okay, now kita pergi yang ni pula. 0.6 fraction. 0.6 ni is actually 3 bahagi 5 kan kat sini, right, isn't it? Log base A. So 3 bahagi 5 darab dengan A. Obviously kita akan gunakan this one mencerminkan multiplication rule. Yang sinilah sama dengan kat sini. So apa yang you buat adalah tambahlah log A yang ini tambah dengan log AA. Log base A, A. This one kita dah tahu kan, dah boleh tahu dah apa benda ni kat sini ni. Okay, nampak kan ni adalah 1 ni. Okay, apa yang kita buat. Tapi yang ini adalah melibatkan lagi satu law which is division law. So dapat yang inilah. Log base log 3 minus log 5 and then plus 1 because of this one ni minus, right? So baru kita gantikanlah log P itu adalah log 3 adalah Q minus P plus 1. So nampak you dah express dalam bentuk Q and P for both questions here. Okay, next questions. Okay, yang ni adalah change the base. Changing the base. Okay, change the base tu macam ni ya. Okay, let's say we want to change the base kat sini. Kalau log A, this is base A, B, you want to change to base C, akan jadi log C, sini base C, yang ni adalah B over log A. Where the, ni kan yang ni B, yang ini akan jadi A. So log B over log A. Any base that you prefer kat sini. Okay, itu yang kita akan gunakan. You can change the base, the base of log 2 to any base, depends so much on questions. Okay, the first one dia bagi kat sini, given that log 2 base 3 is equals to T, express each of the following in terms of T. So sekarang kita mesti menggunakan log base T. Soalan log base 3. Soalan pertama, soalan ni dia menggunakan base 2 kan? So bila dia gunakan base 2, kita tulis dahulu soalan dia. So you kena gunakan base 3. You change the base, it will be this one. So log base 3 kan 9 over 2. Base dah bertukar. Okay, 9. Because of this one is 9, this one is 2. Itu je clue dia. Okay, from here, this one adalah base 3 kan. This is 3. You can express this in terms of 3. Base 3 kuasa 2. So like this. Okay, and then from here kita akan gunakan kuasa tu, power rule tu, power law tu, change the base to base 3 here. This one. And then for this part, kita dah tahu dah jawapan dia kan, which is log 2 base 3 adalah T here. Kita nak tukarkan kepada bentuk T. So you akan dapat kat sini like this because of kita gunakan log ni. This one yang log base 3 ni akan jadi 1. And yang ni akan jadi 2. 2 darab 1 adalah 2. So you akan dapat answer is 2 over T. Okay. Now kita pergi the second one. B ni. Log 9 over 4 base 2. So kita tukar dahulu pada base dahulu. Okay. First of all, this one melibatkan bahagi kan. So kita tolak log 9 minus log 4. Base 2. Next step, kita tukarkan kepada base 3. So it will be log 9 base 3 over log 2 base 3. And then minus dengan this part pula. Log 4 base 3 over log 4 base 2. This part yang bawah denominator ni dah tahu dah, which is T. For this part, yang 9 ni kita tukarkan kepada 3 kuasa 2. Change to base 3. So you akan dapat macam ni lah. Okay, whereby log 3 base 3 is equals to 1. For this part, dia akan jadi T yang 2 ni letak ke depan. So you akan dapat 2T minus 2T over T. This one you boleh simplify. You get 2 over T minus 2. This is the final answer. Okay. This is the changing the base. Now, next. Okay. Almost. Example 24. Kita nak solve the equations here. Solving. Solving means to find the value of x or unknown or y or whatever here. Solve the equations of this one by equation of 4 to the power of 2x minus 1 equals to 7 to the power of x. Giving your answer in 3 decimal places. Solving. First of all, kita tulis soalan. Okay, this one is like index, isn't it? Indices. So kalau indices, how to solve it? Normally kita akan equate dia punya base. But from here, obviously, you can see that you can never express 7 in terms of 4 or whatever. In base 4 or base 2, tak boleh. So no way, there is no way for you to solve this. Gunakan indices, tak boleh. So bila kita tak boleh solvekan any equations ke apa menggunakan indices, kita terpaksa menggunakan logarithm. So what you should do is, you log both side of this equation dengan log base 10. Okay, kita logkan dia. Okay, untuk both side dengan log base 10. Now, bila kita dah logkan yang ni, gunakan log base 10, definitely log base 10 4 ni kita boleh guna calculator je. So, but this one is the index dia kan. Index ni kita gunakan power law tu untuk yang logarithm tadi kita dah prove kan tu. Kita bawa, it seems like we bring this over here, ke depan ni. Yang ni pun sama, x tu kita bawa ke depan. Now, what we do is, kita nak eliminate this one. This part. Because we want to find x kan. So, maknanya kita divide dengan both side dengan log base, log 4 ni juga. Because we want to eliminate this log 4 base 10 ni. Okay. Kedua-duanya biru tu kita kena bahagikan lah dengan dia. So, automatically this one dah eliminate lah. So, yang tinggal adalah yang ini je. 2x. Okay, minus 1, it is equals, this one you can find it using a calculator. So akan jadi 1.4037x, and then this one dah macam algebra biasa je. You akan dapat x is equals to 1.6007. Okay, oh ni lupa pula nak betulkan. Dia nak 3 decimal places kan. So teacher dah tersilap ni. Ni kosong ni you kena buang lah. Tak ada kosong sebab dia nak 3 decimal places. So this is no. 1, 2, 3, 1.677. Okay, kita pergi next question. Solving this one pula. So solving this, okay, dia ada base yang sama, right? Okay. You have different base here, 1x, 1 dengan 3. Okay. The first thing that you should do is equals to 2. Other two methods can be solved here. I'm going to show you both method. So the first one, kita write the questions first. Then from here kita nampak minus kan. Normally when we want to solve the logarithm, kita kena jadikan dia single log. Itu adalah petua dia, kena jadikan dia single log. Okay. I think I made a mistake here. Silap typing error, I'm very sorry. So this one is not x, this one is actually 3. Very sorry for that, log base 3. This one also log base 3. Dia dah betul-betul jadi salah kat situ kan, log base 3. Very sorry for that. So dah betulkan kat situ. So bila melibatkan minus here, kita boleh combine jadikan dia single log. So dia akan jadi log base 3 5x over 2x minus 1. So equate it 2 kan, kita jadikan dia 2. So method pertama, the first thing, because you dah tulis, you have write it in single log here. So what we do is kita tulis dia dalam bentuk index form. Okay. You write it you change this one to indices. Ni 3 kuasa 2. So you akan dapat macam ini. So this one, remember this, how you convert from log to indices and indices to log, this is how you do it. So kita buat kat sini. So yang ni akan jadi 9 and kita solve kan. So to eliminate this, kita just multiply both side dengan 2x minus 1 and automatically yang ni dah being simplified. So 5x is equals to 18 minus 9. So you solve it, you get x is equals to 9 over 13. Okay, dapat. Itu method pertama. Kita tukarkan kepada from logarithm to indices. So kalau method kedua pula, kita jadikan dia kedua-duanya kita logkan dengan base 3. For this one, kita start from the second step here. Okay, kita dah combine them. So next step, kita logkan yang ini, log base 3. So this one kita multiply dengan log base 3 because this one is actually 1. Kan, betul tak? Kemudian kita naikkanlah yang ni, kita jadi gunakan kuasa base power law kat sini. This one power law will be like this, 3 to the power of 2 because of this one, kita jadikan power law kat sini, right? So baru kita compare, you just compare this one and this one. 5x over 2x minus 1 equals to 9. And the process will be the same from here. Dah sama dah macam yang belah kiri. So you akan dapat answer pun sama juga. It is either one. You nak gunakan index ke ataupun you nak logkan. Tak kisah mana-mana. Still can. And next question. Second last questions. Okay. Equations of here. Log x base 3 minus log 81 base x. Tak sama kan kat sini log dia. Base tak sama. Bila base tak sama tapi dia macam single lah log ni. So first thing that we should do is kita nak eliminate this one dahulu. We want to eliminate this part dahulu. What we do is we just add both side dengan, okay, we want, it seems like you want to bring this over there lah. So kita gunakan istilah yang betul. We just add both side dengan log 81 base x like this. So automatically this part dah eliminate lah, being eliminated. So yang tinggal adalah yang ini. Okay, akan jadi yang macam ini. But both are single log. Semuanya single log kedua-duanya. Now, daripada sini kalau kita nak compare it, definitely kita kena samakan dia punya base kan. So this one kita kena change the base lah to base 3. So what you did is yang inilah log base 3 81 over log base 3 x. Macam tu. So lepas kita samakan kat situ, kita change the base. So automatically this one, kita nampak kita nak hilangkan fraction, kita darab dengan kedua-duanya dengan, okay, this one I'm changing the base. So this is how I'm changing the base here. So for this one, you want to eliminate this part yang denominator, kita multiply with the denominator itself. So like this. Automatically this one being simplified. ke atas ni akan jadi darab kat sini. So this one is actually log x square. You akan dapat log x square kat sini. Nampak tak? Dia square. Dia bukannya log x square. Okay, dia tak sama just to remind you. This one. Log x, log base 3 x square is not equals to log base 3x. You squarekan both ni. Tak sama. It's not equal. This one is actually yang inilah ni square. So now this one kita nak normally kan kita this one is actually 4, isn't it? This one 1. Nilai dia adalah 1. So this one 4 ni kita gunakan the third law, kita letak ke depan akan jadi 4 lah macam ini. This one. Okay. Kita nampak dia kuasa 2 kan. So teacher gunakan cara yang mudah untuk awak. So yang because of we want to eliminate the power here. Kita okay, from here kita tahu bila set 4, a square root of 4, you are going to have two values which is 2 and negative 2. Okay, daripada sini baru kita dapat selesaikan, kita ambil yang ni dahulu negative 2. This one kita tukar yang ini dalam bentuk index. You tukar pada bentuk index akan jadi 3, x equals to 3, base this is index isn't it? So 3 kuasa negative 2. Tukar pada index, you get 1/9 for first answer. The second answer, we equate it to 2 pula. Log x base 3 equals to 2 and from here kita tukarkan kepada index form, you akan dapat x is equals to 3 kuasa 2 which is 9. So you're going to have two values here. So tengok kat sini lah Okay, this is the answer. And the final questions, example 27, okay, is a kind of applications in Surds logarithm semua ni. Okay, it's about company saving n years, is a company saving after n years is 2000 and you are given this formula. Okay, in bracket 1 plus 0.07 power of n. Determine the minimum number of years for their saving to exceed 4,000. So first of all kita tengok, this is the formula to find the company's saving which is 2,000 times 1 plus 0.07 power of n. Okay, kemudian ada perkataan exceed 4,000 kan. Kalau ada perkataan exceed 4,000 maksudnya after n years company's saving more than, exceed adalah more than 4,000. So, and this one is, we are talking about the company's saving, we are talking about the formula. So, you just substitute the formula into this explanation here, you get this lah, 2,000, you just substitute the formula here, it is greater than 4,000. From here, we want to eliminate this 2,000, so you just divide it both sides dengan 2,000. So automatically ni dah simplified, being simplified. So you get this one akan dapat nilai dia 2 kan kat sini, right? So 1 plus 0.07 power of n greater than 2. So this one definitely kita tak boleh nak solve kan gunakan indices. So what you should do, you logkan both side, left hand side dengan right hand side, kita logkan jadikan macam ini. Log juga kan base 2. Okay, this part bila ada log ni n tu, this part n tu kita gunakan law, the third law. N bawa ke depan ni kan dapat menjadi macam ini. Okay, this one definitely kita boleh cari guna calculator, this one as well. So to eliminate this, kita multiply both side dengan log base 10, 1 plus 0.07 like this. Kita nak eliminate this part, kita nak express n saja. Jadikan n as a subject. So this one you get this lah. So you gunakan this one dah tak ada dah. Tinggal yang ini gunakan calculator, you get the value of this one. So 10 is greater than n is greater than 10.2448. Okay, they're not number of years. So number of years is referring to the integers. So what is the integers after 10.28? The smallest number of integers which is greater than 10.2448 kan? Definitely lah ada banyak nombor kan, kalau greater than 10 tu 11, 12, 13, tapi dia nak the smallest, the minimum. So it is lepas 10 adalah nombor 11. So number of years will be 11. So this is all that kita sempat terkejar-kejar kan. It's quite fast juga. I'm very sorry for that. So this is basically what we have learned before. Kita just nak recap balik, nak recall balik, nak refresh balik. So apa yang kita dah buat hari ini adalah this one. Okay, kita dah belajar summary of chapter 4. Overall kita belajar indices. We learn about laws of indices kat sini. So kita dah belajar laws of indices. Basically it's about the revision untuk form 3. All of these laws kita tambah dengan sedikit problem solving, and we learn about surds in this one to rationalize it. We learn about conjugate, and we learn about the things irrational and irrational untuk dalam surds ni, and we learn about logarithms. We learn about dia punya laws of logarithm, and also you convert from logarithm to indices and indices to logarithm. Basically this is what we have learned, and also changing the base of log. Okay, kenapa kita perlu belajar ini is very important, very crucial for you to master this one. Why? Because of this one, dia selalu ada dalam kebanyakan topik dalam additional maths. Indices, for instance, you can find it in geometric progression, you can find it in simultaneous equation, or also linear law. Surds, you can find it in trigonometry, coordinate geometry, vector, and also calculus. Kita akan jumpa benda-benda ni, surds ni dalam these topics. And also logarithms. Always kita jumpa dalam geometric progression and linear law. Linear law is one of the topic that you have to score 10, perfect 10 ya. And then in order for you to score linear law ni perfect 10, you have to really master logarithm and indices. Sebab dia banyak guna logarithm, indices, and also sometimes surds. So it's very important for you to understand this, to really master these topics. So teacher rasa itu saja yang sempat teacher share dengan you. Kita sempat belajar apa yang refresh balik. Okay, apa yang silap, apa yang kurang tu teacher minta maaf. Definitely akan ada yang tersilap, ada yang terkurang. Minta maaf ya. Itu je sempat hanya 2 jam saja yang sempat kita bersama, yang sempat teacher share dengan you. InsyaAllah you dapat manfaat sikit daripada apa yang teacher dapat, yang teacher share ni. Okay. So untuk dapatkan apa yang slide teacher ni, segala nota tu, you boleh scan the QR code tu. And don't forget untuk series Skor A plus mathematics, the next one boleh refer ada kesilapan ke apa. You all stay safe, stay home. Itu je. Okay, bye semua. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Okay, Cikgu Hazlina, terima kasih atas perkongsian sebentar tadi. So nampak pelajar memberikan komen-komen yang positif untuk ulang kaji pada malam ini. So diharapkan sangatlah dapat membantu para pelajar kita lah dalam mengulang kaji semula bagi tajuk indices, surds dan juga log ini. Okey, jadi pelajar-pelajar semua tolong jangan lupa untuk isi form kehadiran dan nota kami akan share juga di grup Telegram. Okey, mungkin producer kita dah sharekan di grup Telegram untuk nota penuh bagi kelas Cikgu Hazlina ni. Jadi jangan lupa untuk bersama kami semula pada 10 hari bulan nanti untuk tajuk yang seterusnya, iaitu tajuk progression bersama dengan Cikgu Hasniza pula. Okey, jadi jangan lupa untuk tarikh itu nanti. Okey, so sekian saja daripada kami. Jadi kalau ada apa-apa kekurangan, mungkin ada soalan yang kami kurang faham, tak dapat nak jawab, jadi saya mewakili semua fasilitasi yang betul tugas pada malam ini. Kami mohon maaf, tapi masing-masing insya-Allah boleh refer kepada guru masing-masing di maktab juga nanti. Okay, so sekian daripada kami. Assalamualaikum warahmatullahi wabarakatuh.